Hello, my name is Jack, and I will be your instructional guide. In today's statistics lesson, we are going to analyze independent probability events. At the end of this lesson, students should be able to do three things. First, they should be able to explain the meaning of a probabilistic event. Next, they should be able to calculate the probability of a single event. Thirdly, students should be able to calculate the probability of multiple events.
When it comes to probabilities, a random independent event has a finite number of possible outcomes. Each outcome has the same chance of occurring. A probability for that event is calculated by taking the desired outcomes and divided by the number of possible outcomes.
For this lesson, we're going to look at two independent probabilistic events: a coin toss and the roll of a die.
Let's use a coin for our first example. As we know, a standard coin has two sides. One side is heads and the other is tails. If a coin is tossed into the air, it has the same chance of landing on either side. We can thereby calculate the probability of the coin landing with the head side facing up. So heads is the one desired outcome. That is divided by the number of possible outcomes, which are heads and tails, or 2. So the probability of the heads is 1 out of 2, 1/2, or 50%. Let's do another example, this time using a die. If it is a fair die, it has the same chance of landing as a 1, 2, 3, 4, 5, or 6.
If we roll a single die, what are the probable outcomes?
If we want to determine the probability of rolling a die and it being a 1 or a 2, we would first take the two desired outcomes of 1 and 2 and then divide it by the 6 possible outcomes. This would give us a fraction of 2/6, or 33 1/3%. Now let's consider the probability of multiple events happening. Let's say we're flipping a coin and rolling a die at the same time. What is the probability that the coin is heads and the die is a 1 or a 2? We showed earlier that the probability of a heads is 1 over 2. We also showed earlier that the probability of rolling a 1 or a 2 on a die is 2 out of 6. To find the probability of both events happening together, we must multiply the probability of each event, or 1/2 multiplied by 2/6 is equal to 1/6, or 16 2/3%.
In concluding our lesson, students should now understand how to calculate basic probabilities for single independent probabilistic events and multiple independent events.
That marks the end of this presentation. I hope you've learned something and find a way to use this knowledge to better yourself.